In this video, we are discussing concepts and dimensions of machine learning. So, learning is equal to improve task T with respect to performance measure P and based on the experience E. So, that is very important. So, we know that in case of machine learning, we are applying artificial intelligence to the computer so that the computer can learn from the data. So, obviously, we should know that what is learning. So, learning is equal to improve task T with respect to performance measure P and based on the experience E. So, as an example, if you go for the spam filtering. So, here T is the respective task. So, identify spam emails. Next one is the P. So, P is actually will be denoting the performance measure. So, percentage of spam emails filtered correctly and percentage of non-spam emails that were filtered incorrectly, that is a false positive. So, that will decide the respective percentage. That means the percentage of spam emails filtered correctly and percentage of non-spam emails that were filtered incorrectly, that is a false positive, will be denoting the performance measure for this case study. And E, what is the E? E is our experience. So, database of email labeled manually by users. So, let us go for another one, a checkers learning problem. So, task is T playing checkers and the performance measure P will be percentage of games won against the opponent and training experience E will be the playing practice games against itself. So, this is another example we have considered here. We can specify many learning problems in this fashion, such as learning to recognize handwritten words and learning to drive a robotic automobile autonomously. So, these are the different examples. Here we have considered two of them, but so many examples we can give right now. So, that is a learning is equal to improve task T with respect to performance measure P and based on the experience E. You should remember this very particular line and statement. Another example is that is our signature matching. So, T, that is a task, is our determine if signature belongs to correct person. So, that is a task. So, performance measure, so that is P, percentage of signatures that were correctly matched and percentage of valid signatures that were incorrectly labeled as not matching. Next one is the E. E stands for the experience and database of signatures known to be of that person. So, this is the signature matching, that is another example of this machine learning. So, now we shall discuss what is dimension of learning and what are 5 dimensions of learning. So, dimensions of learning is nothing but one comprehensive model that uses what researchers and theorists know about the learning to define the learning process. And there are 5 types of thinking, what we call the 5 dimensions of learning, and are essential for a successful learning. So, let us go for the dimension number 1, that is attitudes and perceptions. So, attitudes and perceptions affect students' abilities to learn. For example, if we can find that if students view the classroom as unsafe and disorderly place, then obviously the student will not be liking to use that place for their learning process. So, they will learn little there. So, that is known as the attitudes and the perceptions. Let us go for the dimension number 2. So, acquire and integrate knowledge. So, when students are learning new information, they must be guided in relating the new knowledge to what they already know and organizing that information and then making it a part of their long term memory. So, whenever the student will be learning, then that learning should get integrated to their previous knowledge, so that the learning will be having a long term memory in their respective brain. So, we are having this one, that is our dimension number 3. So, extend and refine knowledge. So learning does not stop with acquiring and integrating knowledges. So learning cannot stop, it will go on acquiring and it will go on integrating the knowledges which will be coming next. So learners develop in-depth understanding through the process of extending and refining their knowledges. Next one, we are going for the dimension number 4. So use knowledge meaningfully. So the most effective learning occurs when we use the knowledge to perform some meaningful tasks. We might be having different knowledge, but which knowledge has to be applied to one task for the meaningful way, that is a great skill. So for example, we might initially learn about the tennis rackets by talking to a friend or reading a magazine article about them. Next one, we are having the dimension number 5, that is the last dimension, that is the habits of mind. The most effective learners have developed powerful habits of mind that enable them to think critically and think creatively and regulate their behavior. So in this way, we have defined what are the different dimensions of learning, and there are 5 different dimensions. We have discussed each one of them one by one. Thanks for watching this video. In this video, we are going to discuss the learning process. So what are the different steps through which our data set will be ready, and that will be given to a model for the learning, and that we are going to discuss here. So this is our real world. So the first step will be there from the real world. Data gathering has to be done at first. Then we will be going for data pre-processing, dimensionality deduction, model learning, and then model testing. And then our data will be ready for the analysis of the unknown data for the prediction. So this is the basic steps in our learning process. So at first we are going for the data gathering. This data gathering can be done from different devices, from different transactions, from camera, from sensors, from databases, and so on. So there are multiple different sources from where we can gather our data. But whenever we shall gather our data, that data may not be in a good format, so that's why you will be going for data pre-processing, where in this case you will be going for noise filtering. If you find that some data are corrupted, some data are biased, so in those cases this noise filtering has to be done so that we can get our data without any noise. Next one, we are going for the feature extraction and normalization. After doing this noise filtering, our data will be obtained, which is free of noise, but sometimes it may have some missing values. So some of the attributes, some of the fields for a certain row or record might be having no value. In those cases, the missing values are to be resolved. Then we will be going for the feature extraction. We might be having, say, thousands of attributes, might be having hundreds of attributes. If you go on working with all those attributes, the computational complexity will be too high and the model will be functioning very slow, and all those attributes may not be required at all. So that's why we should find out those principal attributes which are required for the prediction purpose and which will be required for the learning purpose of the model. So this particular model should be learned on those particular set of attributes which are relevant and principal attributes. Then the normalization. Different type of attributes may have different minimum value, maximum value. The age of a person, for the particular database, we have found that the age of a person is ranging from, say, 20 years to 80 years. The height of the person is ranging from, say, 4.5 feet to 6.5 feet. So in this way, we are having multiple different attributes and they are having different set of or range of data. So all these data are to be normalized, are to be scaled so that they can be processed for learning. Next, we will be going for the dimensionality deduction. Here we will be going for feature selection and feature projection. So in case of feature selection and projection, we are trying to find those attributes which are relevant for our learning process, for our prediction process. Also, we can assign some weightages on those attributes. So attributes with some higher weightage will be more relevant. Attributes with the lower weightage value will be less relevant. So these processes are to be done in our dimensionality deduction. And then we will be going for this model learning. We can go for the classification, regression, clustering, descriptions, and so on. In case of classifications, let us suppose there is one credit card approval data set where applicants certain personal details are written, say their age, their sex, their income, their savings, their say the respective their whether they are having their own house, whether they are having their own car. So all these details are there, and then we are having a past data which is depicting that whether these particular persons have got the sanction for the credit cards, yes or no. So approved and not approved. In this way I am having a set of data. So on that particular set of data I shall make my model learn. Now when I shall give some new applicants information to my model, the model will tell us whether the credit card should be approved to him or her, or should not be approved to him or her. So that is known as a classification. So classification means we are having two classes in this problem, whatever I have discussed. That is, approval will be done successfully or not approved. So approved and not approved. So these are the two outcomes. So we will be calling them as two classes. So what will happen when a new data set will be given, then our model will predict whether approved or not approved. So it will go for a certain class. So that is known as the classification. Whenever we are having our data in a continuous fashion, then we can plot x and y for them using some regression, and then using some graphical representation, and then we can draw one line through those points which is known as a regression point, so that for a new value of x I can predict a new value for y. So in that case the regression can help us for the prediction purpose. We are having this clustering and descriptions. So in case of clustering, what we can do, we can select those data sets in a certain group which are having some common similarities or having some distance within a certain bound. So that is known as the clustering. So in this way, in case of model learning, different types of algorithms can be used. That is a classification algorithm, regression algorithm, having the clustering algorithm, and so on. After making the model ready, then we shall go for the model testing. So here we are going for the cross validation, bootstrap, and so on. So this is known as the model testing. In the case of cross validation, what will happen? Our data set, a portion of the data set will be used for the training, and another portion of the data set will be used for the testing. So as I am taking our testing tuples from the data set, so we are having our labels and outcomes known to us. So now I shall check how far my model is doing the prediction correctly. So that is known as the respective cross validation. Now in case of bootstrap aggregating, also called bagging, is a machine learning ensemble meta algorithm designed to improve the stability and accuracy of machine learning algorithms used in statistical classification and regression. So this particular bootstrap is actually a process with the help of which we can increase the ability and the stability and accuracy of our machine learning for the correct prediction. So regarding all these aspects, in our tutorial we are going to discuss so many different issues. So in one slide, obviously all the issues cannot be discussed. So but each and every aspect we have discussed in our tutorial with some examples, with some implementations and all. So training data, that is our past data, that will be given to this model for the learning purpose. And now test data, that is our future data, will be given to our model for the prediction. So gather data from various sources. So that is our step number 1. Clean data to have homogeneity. Build model, select the right machine learning algorithm which is applicable there, and gather insights from the model's results and visualize, that is transform results into some visual graphs. Obviously having data in a table and having the graphical representation of the data will be more comprehensive. So transform results into the visual graphs and representation. Randomly split examples into training set U and also test set V. Use training set to learn a hypothesis H and measure the percentage of B correctly classified by age, and repeat for different random splits and average results. So we can split our data set randomly into training set and test set, and we can go for the performance evaluation, and then we can average those results to decide the efficiency, ability, accuracy of the model. So overfitting, what is overfitting? The model learns the training set too well, it overfits to the training set and performs poorly on the test set. So when the model will be tested with our data set which is pre-known to us, it is performing okay, the training set is on the training set it is performing okay, is very good performance, predicting most of the time correctly, but when the new data set will be given to it, it is performing very poorly, and in that case we can consider that overfitting is the problem. So underfitting, when the model is too simple and both training and test errors are very large. So in this way we have discussed multiple different issues in this particular video. Please watch the next video also, because that video is also in the continuation of this particular video. So watch the next video where we will be discussing different aspects into further details and what are the 3 different categories of machine learning model that will be also discussed. Thanks for watching this.